Good morning. Welcome to Facebook workshop. In next 20-25 minutes, I'm going to talk about Facebook's latest servers and machine learning servers as well. I'm going to do a quick overview about Facebook's hardware, and I'm going to cover these three kind of major server that we're deploying to our data center today. So we have one socket server, which is like low power SoC card. This is mainly for our web-based services. And then we also have two socket server, Tiago Pass. This is high performance server with high memory and also high I/O deployed for data center for this like high compute, high memory, high I/O demand services. And we're deploying our big basin, which is with 8 NVIDIA GPU today. We deploy this mainly for our machine learning training services. Many CPU together, many GPU together. This is very good for convolutional neural network kind of based machine learning services. In past 8 years, Facebook has experienced tremendous growth. So we're from growth from 600 million active monthly users to 2.2 billion active monthly users today. During this time, we also add Messenger, Instagram, and WhatsApp. Each of these applications has strong demand for our hardware, server, storage, and network gears. So, for example, we have photo, video upload, and we have user requests, cache requests, database requests, this kind of service that they have strong demand for our hardware. Here, give you an overview like over the years, how many hardware Facebook has contributed to OCP from 2011 to 2018. So today, this year, we contribute our Big Basin V2 and Twin Lakes, which is based on Intel latest Skylake-D SoC card. This year, like Joshua just covered OCP NIC 3.0 spec, we also contribute to OCP. Okay, so yeah, and then I'm gonna switch to our server. So first is our one socket server, Yosemite V2. Yosemite V2 is our one socket server. So this is an overview about the server, and this is based on modular design. So you see we have, except for the Yosemite V2 chassis with the baseboard, we have different modular that for different configurations. This is a NIC module. So NIC module, we can support either 50 gig NIC or 100 gig NIC, which is based on Yosemite, based on NIC 2.0, OCP spec 2.0. And then for these 4 slots, we have 4 slots, and these 2 slots we call slot 1 and 3. For 1, 3, we can put different kind of modules. Here we can put CPU modules and also M.2 carrier card and PCIe cam card. I'm gonna talk a little bit more about these 3 different modules. And then for slot 2 and 4, we can put our Twin Lake module, which is CPU-based Twin Lake. So Yosemite V2 is ORV2, OpenRAC V2 compatible, and it can support hot services. I'm gonna spend a little bit more time talk about our hot services, which is the major difference from our Yosemite V1. And for this Yosemite, we enabled dual ODM. We worked with Quanta and WinWin for this platform. And this is also EMI safety compliantable. For the slot 1, actually 1 to 4, we can put 4 of this kind of module we call Twin Lake. This is based on Intel Skylake-SD, and in Facebook we're using the 18-core version of the CPU, and it has 4 memory channel, 2 DIMM per channel, support DDR4 2400. And then on the back side, we actually have three M.2. So one of them you can use as a boot drive, and the other two you can put M.2 as a flash cards. So this is the M.2 carrier card. We call this Glacier Point. Glacier Point is the M.2 carrier card. So if you remember slot 1 and 3, we actually can put this card. This is basically they have by 24 PCIe connect to this card, and we can support up to 6 M.2s. And then we are also working on the Glacier Point V2, which we put a PCIe switch on the card. So, and then we have a 6 more M.2 on the bottom side of this module. So Glacier Point V2, actually we can support 12 M.2 modules. And this is a PCIe CAM adapter card. Basically just convert the form factor to standard PCIe CAM card. Okay, hot service. Hot service is basically, when you have a 4 twin lake cards running into the Yosemite V2 system, that when you do the service, one of them or two of them, you need to do the service. Hot service means that you don't have to power off the whole Yosemite V2 chassis. You can pull out the chassis that the power is still there, and then you can, for example, one of the twin lake car trigger an event that need a service. Then we can trigger that event. Then we can power off that particular slot, and then. Running here, okay, and then we can turn on one of the LED indicate which slot you need service. So the LED will blink, and then you're gonna pull up the chassis, and then do the services, and then put the new car back. In this case, the rest of the three twin lake are still working. And then you do the car insertion, power on the slot, turn off the light, and then put it back. In this case, the rest of three are still working during all the services. How do we achieve that? If you see, we actually have the power bar together with the eBrush underneath the server. When you pull up, all the power is connected, and this is so in the middle. This is like a 3D CAD to indicate what's the eBrush connector look like, and then we also have Yosemite V2 in our booth. You can have a detailed look about the how it works. Okay, then I'm gonna switch to our 2-socket server, Tiago Pass. Tiago Pass is Facebook's general purpose 2-socket server. This is designed for high performance and high memory services. We also do modular design, especially like from the I/O side, because we have a by 32 PCIe, so we have different modules to support different configuration. And we designed this server, it's really for easy services. So except for the CPU, you don't need any tool to do the services. For example, for the DRAM, for the NIC, for the hard drive, and the I/O, you can do these services by hand. And we designed this server like open. We also collect feedback from the community and improve our design like over generation. Here I already covered a little bit. So this server is based on Intel Skylake SP processor, and then we can support up to 165 watts. And in this picture, it's actually single-sided. We actually have both single-sided and double-sided SKUs. Double-sided means that in the PCB, we actually have a DIMM on both sides of the PCB to maximize the memory configurations. Here, from the picture, you see is a single-sided, which is 1 DIMM per channel. We support up to 12 DIMM per Tiago Pass server. And on the I/O side, we have a PCIe riser car, which can support up to by 32 PCIe, but we have different configuration by 2 by 16 or 1 by 16 plus 2 by 8. We call that a 2-slot or 3-slot riser card. And from the boot drive point of view, you can either use a hard drive, 3.5-inch hard drive as a boot drive. You can also use M.2 as the boot drive. It's on board. And from NIC side, OCP NIC 2.0, we support up to 100 gig. And then majority of services will actually deploy with 25 gig only to save the cost. And this is a 2OU. Each 2OU we can support like a 3 Tiago paths here is ORV2 compatible. Here I spend a little bit time talk about the performance. Performance here, we actually means the CPU performance, but we don't always just use whatever highest power SKU from Intel. We actually work with Intel to customize our CPU. So basically, we have our rack envelope. ORV2 support 2.6 kilowatt per rack, and then we based on the rack power envelope and also the density of the servers, we lock down some of the CPU SKUs, and then we work with Intel. They actually explore some of the parameters for you to tune, like the TDP, like the core count, frequency, and even the T-case. If you have enough thermal margin that you can also tune the T-case to gain some, for example, 1 bin for the turbo. So we work with Intel to fine-tune these parameters to see which CPU SKU, which combination of these parameters may give us the highest performance per watt output. And then we lock down the CPU SKU to get the best performance per watt to improve the efficiency. All right, and then I'm gonna switch to our machine learning, Big Basin. So Big Basin is it's a GPU expansion box which we designed for our machine learning workload. There are many different kind of machine learning services in Facebook. For example, when you open your Facebook page, you do search, and you probably see some of the ads. And for example, some news feeds right on the right side. And also, when you upload a picture or whatever video, it may tell you who is this, who is that, to do the rack, we call like rack recognition. So these services are all machine learning services. And then these services are running into our machine learning hardware. So over years, start from 2016, Facebook has start our machine learning hardware design. 2016, we contribute our Big Sur server. And 2017, that's Big Basin V1. V1 use our previous server generation Leopard as the head node. And then this year, we contribute Tiago Pass plus Big Basin V2. We design these servers like we contribute to OCP already. And in Facebook, our design concept is we want to do disaggregation design, modular design. This allow us to improve the technology over time, just swap the module. And then serviceability is one of the key requirement that during the design. So think about this, the volume like we deploy to our data center. Serviceability is really the key point here. We have to keep in mind during the design. This is a rack overview, like how Big Basin being shipped. So each of the rack, we actually have 4 different Big Basin V2 together with the handle. This is we have some space left there. This is mainly because of the rack power envelope. So Big Basin V2 is a 3OU chassis. This is ORV2 compatible, and each of the Big Basin, I'm gonna switch to here. Yeah. So each of the Big Basin has 8 NVIDIA Volta 100 GPU on board. And these 8 GPU, they are connected with full NVLink mesh. Each of Volta is 300 watt, and we use a Tiago Pass as the head node. Yeah, this is a closer look about inside of the big basin. So we have a backplane board, and we have the base board, which holds 8 of the module, and then we also have the I/O board. So you can see from the left side pictures. So the baseboard actually sitting in a slide tray. So when you do the services of either of the GPU, you pull out the sliding tray. You don't have to have the whole chassis coming out and do the services. And here, between the left row of the GPU, we have a PCIe bridge card. So this PCIe bridge card is it's to deliver the PCIe signal from the head node side. So we have a cable connected to this PCIe card and then to this box. I will not spend much time to talk about the performance, but this performance is based on NVIDIA website. From Gen 1 to Gen 2, we upgrade the NVIDIA P100 GPU to V100. So basically, if you see FP32, and the performance actually improved 42%. And then for NVIDIA, this generation, Volta generation, they actually enabled the Tensor Core, which can improve the IP16 performance by 5 times. And NVLink speed also improved like 88% from 160 gigabyte per second to 300 gigabyte per second. So compared with our last generation Big Basin V1, we upgrade the GPU module. I just covered about it, and then for the head node side, we upgrade from our last generation Leopard to Tiago Pass. So basically, it's Broadwell to Skylake upgrade, and then from I/O side, previously we only have by 24 PCIe. Now we improved to by 32, and also from NIC side we upgrade to support up to 100 gig NIC. And Big Basin V2 is not only like hardware upgrade. We also upgrade NVIDIA CUDA 9 plus the CUDA library, which give us like a higher performance. So if you have any more questions, you can click the link and then get to know more about Facebook's hardware. And all these 3 projects we have contribute the designs and then the specs on the OCP website. All right. Yeah. I have a few more minutes. I'm going to take questions.
Okay, thank you, Whitney.
Yeah, thank you.
Do we have any questions from the audience? Hold on.
Hi. Just one quick question in regards to the Basin 2 version 2. You're using new NVIDIA cards. The question is whether coming away from that advanced cooling project, are you planning to implement any kind of the liquid cooling? Because as you can see with that heat sinks, it's really it changes the form factor. I mean, the density is quite low. So are you planning to do some side projects as other vendors to implement liquid cooling only on that platform?
I actually have Jacob, which is our thermal team leader here. I'm gonna take. Yeah.
So speaking to about the liquid cooling, so we have an AC group that we actually running it to understand what the alternate cooling solution there could be for the future platform, especially for these generations. We are using about 3U form factor heatsink, which is pretty large heatsink that we could cool it up to 300 watts, and it was actually workable. For next generation, and I guess it really depends on how much the power and the temperature requirement going to be. That's why the whole things about ACS created in the OCP to define the spec.
Thank you. Hope Jacob already answered your questions. Any other? All right.
Anything else?
Thank you.
right.
I'll be around on the booth side. If you have any more questions, just feel free to come to us. Thank you.